So for your 14.1 quiz, you need to know the difference between your permutations and your combinations. Remember, your permutations are that N with your capital P with the R, where your order matters, and you have different jobs within. Your combinations, your order doesn't matter, and it's all the same job. So remember, for your permutations, you're going to have N factorial over N minus R factorial for your formula. For your combinations, you're going to have N factorial over R factorial times N minus R factorial. Remember that factorial just means that you're taking the number, multiplying it by itself, times the number less than that, times the number less than that one, and so on until you get to 1. So with the first question, it tells us or asks us, how many different batting orders can a baseball coach create from a team of 14 players when there are 9 positions to fill? You can do this one of 2 ways. You can use your permutation, or you can use like a set of blanks with 9 positions and the amount of players that you are choosing from for each. With this one, the order matters because you cannot replace one person each time, kind of thing. Or sorry, you are replacing, but you're not throwing that person that already went back into the group that's going. So like I said, we could do this 2 different ways. The way that I would do it is I would set myself out 9 different places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. From the first, you have 14 players to choose from. So you put your 14 there. After that person has gone, you have 13 players to choose from. Then 12, 11, 10, 9, 8, and 7, and 6. You will multiply all of these numbers. Another way of doing this is giving yourself your permutation with 14 as your N permutation. Your R would be 9 because you have 9 positions. So if you multiply the 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6, you would get 726,485,760. For number 2, it tells you to consider that 8 sprinters have qualified for the finals in the 100-meter dash at the NCAA National Track Meet. How many ways can the sprinter come in first, second, and third? For this one, again, your order matters, so you would use a permutation. Or you would say to yourself, there's 8 sprinters, so I have a total of 8, 3 of which are getting first, second, and third. So I would do 1, 2, 3. My first one, I would be able to get 8 people to choose from. The second would be 7, and the last would be 6. If we multiply all of this or do our permutation of 8 permutation 3, sorry, not 6, 3, this would end up giving you a total of 336. For number 3, it tells us to find the number of distinguishable permutations of the group of letters given. We have L, L, G, A, and R. You have a total amount of letters here of 1, 2, 3, 4, 5, 6, 7. The ones that repeat are L, which is twice, and A, which is 3 times. To work this out, you are going to have your total number, factorial, over the amount of times that L repeats, which is 2 factorial, times the amount of times that A repeats, which is 3 factorial. This would then simplify to give you 7 times 6 times 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. Your 3 factorial cancels out on the top and the bottom to leave you with the 7 times 6 times 5 times 4, giving you 840 over 2 times 1, which is 2, which gives you a total number of 420 ways. For your next one, number 4, you are given the same set or same type of problem and asked for the number of distinguishable permutations of the group of letters Q, P, P, D, 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 E, 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 E. So for this one, you have a total of 10. Your P repeats itself twice, D repeats itself 3 times, and E repeats itself 4 times. So that means we're going to do 10 factorial over 2 factorial times 3 factorial times 4 factorial. This gets rewritten as 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 2 times 1 times 3 times 2 times 1 times 4 factorial. Your 4 factorial cancels out on the top and the bottom here, leaving you with the multiplication of the 10 times 9 times 8 times 7 times 6 times 5, which is 151,200, over 2 times 1 times 3 times 2 times 1, which is 12. If you divide this out, you would be left with 12,600. For number 5, it tells you that a college student is preparing a course schedule for the next semester. The student must select one of 4 mathematics courses, so we're going to put the 4 down, one of 4 science classes, so that's another 4, and one of 2 courses for the social sciences and humanities. It asks us how many schedules are possible. So we're just going to multiply this out. 4 times 4 is 16, times 2 is 32. For number 6, it tells you that a customer can choose one of 4 amplifiers. I'll write that one down. One of 9 stereo receivers. Write the 9 down. And one of 10 speaker models for an entertainment system. Determine the number of possible system configurations. We're just going to multiply these out. The 4 times 9 is 36, times 10 gives us 360 ways. For number 7, it asks you in how many ways can a 14-question true-false exam be answered. Assume that no questions are omitted. There's 14 questions in total, 2 answer choices for each. So because there's 2 answer choices for each, our base is going to be 2. Our power is the number of questions, which is 14. If we raise 2 to the 14th power, we should get 16,384 ways. For number 8, it tells you in a physiology class, a student must dissect 3 different specimens. The student can select one of 6 earthworms, so that's 6, one of 7 frogs, that's 7, and one of 3 fetal pigs. And how many ways can the student select that the specimens? So with this, you're just multiplying 6 times 7 times 3. The 6 times 7 is 42, times 3 gives us 126 different selections. Now for your set of questions, you have to pay attention to what they're asking you for because you're going to be using your permutation or your combinations for these. For number 9, it tells you that you can answer any 16 questions from a total of 20 questions on an exam. And how many different ways can you select the questions? This one, the order does not matter, so you're using a combination. How many do you have to choose from? 20. How many are you picking or answering? 16. So it's a combination between the 20 and the 16. So this is going to give you your formula of 20 factorial over 16 factorial times 20 minus 16 factorial. That gives you 20 factorial over 16 factorial times 4 factorial. That 20 factorial is 20 times 19 times 18 times 17 times 16 factorial, because we have the 16 factorial on the bottom. And that 4 factorial is 4 times 3 times 2 times 1. Your 16 factorial cancels out on the top and the bottom. So if you simplify this, plug it into your calculator, which you will need for tomorrow, and simplify, you get 4,845. For number 10, it asks you, in how many different ways can a jury of 12 people be randomly selected from a group of 30? For this one, again, your order doesn't matter, so you're using a combination. You're picking from 30, and you're picking 12. So that means you're going to have 30 factorial over 12 factorial times 30 minus 12 factorial. This simplifies to give you 30 factorial over 12 factorial times 18 factorial. So this is going to be a long list, but 30 times 29 times 28 times 27 times 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 factorial over 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 18 factorial. Your 18 factorial simplifies on both the top and the bottom, and this will give you a total of 86,493,225. For number 11, it tells you that a law office interviews paralegals for 10 openings. There are 15 paralegals with 2 years of experience and 22 paralegals with 1 year of experience. How many combinations of 6 paralegals with 2 years of experience and 4 paralegals with 1 year experience possible? So, 10 total openings, kind of irrelevant. The reason why is because it tells you that you need 6 paralegals with 2 years of experience. So that means you're going to have 15 combination 6. And then you're going to need 4 paralegals with 1 year. So that means you're going to multiply that by 22 combination 4. Your 15 combination 6 is going to give you 15 factorial over 6 factorial times 15 minus 6 factorial. And your 22 combination 4 is going to give you 22 factorial over 4 factorial times 22 minus 4 factorial. These both will simplify to give you 15 factorial over 6 factorial times 9 factorial times 22 factorial over 4 factorial times 18 factorial. Both of these then do simplify to give you 5,005 times 7,315, which gives you a total of 36,611,575. For your last question, it tells you that a gym locker will open when the right combination of 6 numbers are entered. Numbers are 1 through 30. For A, it asks how many different ways are possible if the numbers if they can repeat. So you have 6 options to choose from. You have 1, 2, 3, 4, 5, 6. Out of the first, you have 30 numbers to choose from. The second, there's still 30 because you are repeating the numbers. And then the next is 30, the next is 30, and the next is 30. And the last one is 30. So this is the total of 30 to the power of 6. So this will give you 729 million different ways that you can put these numbers in. For B, it asks you how many ways are possible if the numbers cannot repeat. So you, again, still have 6 numbers to choose from. For the first, there's 30. One of those numbers is not repeating, so the next one is 29. Next, you would have 28 numbers to choose from. Next would be 27, then 26, and 25. If you multiply all of these together, or you can also use your permutation, you would get 427,518,000 possible ways.